Okay, we're in topic 1.3. This is areas of regular polygons. It's a continuation, really. We've already done one with triangles. Now we're going to do one using a square. If you remember, the line that connects the vertex to the center point is called the radius. This is the side of this square. The point in the middle is the center. And the line that's perpendicular and bisects the side is called the apothem. And it always is at a right angle, and it's always half the side length. There's another interesting fact on a square. It's actually half the side length here also, because this is a 45, 90 degree triangle, special right triangle that's formed when you draw the apothem and the radius of a square. I think I'm going to show you, especially on ones that give you the apothem. Because this is 9, we also know that this is 9, so really our side length here is going to be 18. So to get the perimeter of a square is just 4 times the side. So if you multiply 4 times 18, you get 72. So that's just your perimeter. Your radius on this one, on a 45, 45, 90, let's draw that. I think I'll put it right up here. It's called a special right triangle. We've worked on these before. A 45 degree right triangle is always isosceles. It always has two sides the same length, and the hypotenuse is always that length times the square root of 2. So I'm going to put that right here in the corner if you can see that. So on this one, this radius would be 9 times the square root of 2. Now for this problem, we'll go ahead and put it on the notes, but you really don't need it when you're doing the area. You can use, and I'm going to show you, you can use two different formulas for squares. You can use the side squared, or since it is a regular polygon, you can also use 1/2 the perimeter times the apothem. So really, you can use either one. It doesn't matter. And so on this one, probably the easier one would be to square 18. But I think I'm going to show you both of them. If you do 1/2 the perimeter is 72, and the apothem is 9. And if you work out both of these, I'm going to do it real quick. 18 squared is 324. This is 324, and if you multiplied 1/2 times 72 times 9, you also get 324. So either method, whichever one you want to do when you have the apothem. Now sometimes you won't be able to do that, but on this one you do. Now a radius is just a measurement, and area, remember, is a square unit. So put square inches for that one. Okay. Example 2. Find the indicated measures of the square below. Again, this one's giving us the apothem, and the apothem is the square root of 2. So if the apothem is the square root of 2, so is half of a side. And if half of a side is the square root of 2, think of taking the square root of 2 and adding another square root of 2. The way you would do this one is, that would mean you have 2 square root of 2. So that really is each side length. I think I'll label that. 2 times the square root of 2 would be each side of your square. So if you have 4 of those, that means that your perimeter on this one, let me do this one. Yeah, your perimeter going around would be 8 times the square root of 2. Because remember, the perimeter of a square is 4 times whatever the side length is, and the side length is 2 times the square root of 2, and that's 4 of those, so that's going to be 8 times the square root of 2. The radius on this one, the square root of 2 times the square root of 2, just like when you're adding, you add coefficients. When you multiply them, though, multiplying the square root of 2 times the square root of 2, you actually multiply the radicand, so you get the square root of 4, which is 2. So on this case, when you, if you're using a special right triangle and you're multiplying the short leg, or either leg, times the square root of 2, your answer for your radius is 2 on this one. Okay, again, the area, you can use either one of the formulas for this one. Since we do know the side length, we could do the side squared, or we can use the 1/2 the perimeter times the apothem. So squaring the side, now when you put the 2 times the square root of 2 in the calculator, let me show you what happens. The calculator puts a parenthesis right here, so you will need to close it, but you'll also need to start with a parenthesis and a double parenthesis at the end if you're going to do it in your calculator. Let me kind of show you that. Let me put this up here. You start with a parenthesis and you type in 2 and then the square root of 2. You're going to do a double parenthesis because you need to close that radical sign, or the radicand, and you need to tell the calculator you want to square the product of those two. So that's why you would have to close both. So the answer of 2 times the square root of 2 squared is 8. So this time your area is 8. Since it's meters, this would be square meters for your area. Let's go ahead and do the optional formula for this one, where you're multiplying 8 times the square root of 2, the perimeter, times the apothem. 1/2 times 8 is 4, so this is 4 times the square root of 2 times the square root of 2. Anytime you're going to multiply a square root times a square root, you do multiply the 2 radicands, so you would get the square root of 4. This 4 you can think of multiplying by the coefficient that's understood, which would be a 1, so that gives you 4 times the square root of 4. Square root of 4 is a perfect square, which means 2, so 4 times 2. See how you get the same answer for if you use either one of these formulas. Okay. Example 3, again they're giving us the radius is on this one 5 times the square root of 2. Let's review real quick just for a minute, make sure you're understanding special right triangles. In a special right triangle that has a 45-degree in 2 of your angles and a 90 in your third angle, your side lengths are always going to be the same that create the legs, and then the hypotenuse is always that side length times the square root of 2. So in this case they've written 5 times the square root of 2. That means both the apothem and half of the side is going to be 5. So that would create a side of 10. You just double this number because you want to get the side length. This little a means the apothem, that's 5. The perimeter on this one is 4 times 10, so that's 40. This one's not given, well yeah it is, I'm sorry, it's a centimeter. And then the area would be, if you just did side squared, that'd be 10 squared, which is 100. And that would be 100 square centimeters. I'm going to go ahead and also do the regular polygon formula, 1/2 perimeter times the apothem. So it's 1/2 the perimeter, which is 40, and the apothem, which is 5. Well, half of 40 is 20, and 20 times 5 is 100. So that's just another option you can use basically for either one of these. You can do it that way. Number 4, example number 4, is this time they're giving us the apothem. I'm sorry, no they're not. They're giving us the radius, and they want us to find out the apothem, perimeter, and area of this one. Okay, on this one, again, the hypotenuse is always on a regular 45, 45, 90 right triangle is always whatever that short leg is, let's call them x, times the square root of 2. So in this case, that hypotenuse is 4. So you're going to divide by the square root of 2 to solve for x. Square root of 2 divided by the square root of 2 is just 1, so you get 1x. Now I'm going to show you something called rationalizing the denominator. In math, the rule of math is you cannot leave a radical in the denominator. So you're going to multiply both numerator and denominator by the square root of 2. And this is called rationalizing the denominator. I'll show you what happens. Rationalizing the denominator just means you're removing the radical in the denominator. So it's 4 times the square root of 2 when you multiply the numerators, and down here this becomes the square root of 4. Now the square root of 4 is a perfect square, which is 2, and because there's a coefficient of 4 up in the numerator, it does reduce with this 2. Now not this one, but the one out as the coefficient. 4 times the square root of 2 divided by 2 ends up being 2 times the square root of 2. You might want to back that up and listen to that again if that didn't make sense, or come talk to me for a second if you're really not remembering or don't understand rationalizing the denominator, because that one is a little bit tricky. But that means that 2 times the square root of 2 is the apothem and half of the side of this square. So if 2 times the square root of 2 is half the length of the square, doubling that gives you 4 times the square root of 2. That's going to be the side length of your square. So if we wanted to use side squared, we would, to get the area, we would take 4 times the square root of 2 and then square that answer. Or if we want to use the formula for a regular polygon, we're going to have to multiply 1/2 times. Now let's talk about the perimeter for a second. Your perimeter would be taking the 4 times the square root of 2 and multiplying that by 4. Now remember, the radicand really doesn't multiply unless there's another radicand, so this is really just 4 times 4 times the square root of 2. So 16 times the square root of 2 is your perimeter. The apothem is 2 times the square root of 2. And then to get our area, there's 2 ways we could do that. This one's going to be a little trickier. Actually, they're both kind of tricky, but if you put this one in the calculator, just remember that you're going to put a parenthesis. While the given parenthesis will be here, you'll have to close it with a double parenthesis and then multiply it. I think I'll show you that again. I can't tell if I'm covering up the notes. Alright, I think this will work. You start with a parenthesis, 4 times the square root of 2, and then remember you need a double parenthesis squared. So the answer to this one is 32. This is kind of good doing it 2 different ways because I can make sure I'm getting it right. But that one came out 32. Let's try the next one. 1/2. I'm going to use a parenthesis. Times 16 times the square root of 2. Remember to use a double parenthesis to close that. And then 2 times the square root of 2. And another double parenthesis to close that one. This is a little trickier, but it's because the calculator puts that beginning parenthesis anytime a radical is used. But I did get 32, so I know I'm doing it right. Again, come see me if this is difficult. This is probably more difficult than the ones we've done so far. But all right, let's go to example 5, last one. I'm going to draw a square. Remember, I do have extra templates you can use if you want to borrow one, or you can just sketch a square. On this one they give us a radius, so remember the radius is the one that connects the vertex to the center, so go ahead and label that 24, and then let's draw a dotted line for your apothem. Okay, this one we're going to work a lot like we did example 4, so remember you always let your side length be x when your hypotenuse, this right here, does represent the x times the square root of 2. So x times the square root of 2 happens to be 24. And just like on number 4, we have to divide by the square root of 2. We get to practice rationalizing the denominator again, because this becomes, now you can't just say 24 divided by 2. That's not what the square root of 2 is. Now remember, to rationalize, you go ahead and put a dot because you're multiplying the square root of 2 over the square root of 2, which this represents a 1. Anytime you multiply by 1, you're just renaming your answer, you're not, it's kind of a simplifying method. This is actually called simplifying radicals. So on this one you do not multiply the 24 times the 2 since it's a radical. But here you do multiply the radicands because they're both underneath. And this one's a perfect square. So if you just do this in steps, and it'll make this easier. The square root of 4 is 2. 24 times the square root of 2. The 2 that's not in radical form and the 24 that's the coefficient, that can be simplified. So 24 divided by 2 is 12. So your answer is 12 times the square root of 2. I think I want to show you something too. If you put in the calculator, trying to keep from getting a glare on here, 24 divided by the square root of 2, the original problem we were about to do. See how it gives you a decimal? If you type in 12 times the square root of 2, it gives you the same decimal, so you know you've simplified it. You've simplified the radical when you can get the same decimal in the calculator. Now if this problem is a little bit excuse me, a little bit easier to do as a decimal, that's fine with me. If you would rather use, I'm going to even write up here 16.9. You may use that for one like this, but I'm going to keep doing this one as a radical. I think it's good practice. So, alright, so if 24 is the radius, then the apothem is 12 times the square root of 2. If 12 times the square root of 2 is half of a side length, then an entire side of this one would be double that, so that's 24 times the square root of 2. Let's just do side squared. So we take our 24 square root of 2 and we square it. I'm trying to get this calculator here so you can see it. Parenthesis 24 square root of 2 double parenthesis squared. That's a pretty big number, 1,152, but look how it came out an even number. I think on this next one I'm going to do the other formula, but I'm going to use the decimal so I can show you, so you can learn how to do this one. It'll come out pretty close, but it'll be a decimal form. Let's talk about that. If the side length is 24 times the square root of 2, and we put that in the calculator, that's about 33.9 if you want to put the decimal answer. So really these kind of mean the same thing. So if 33.9 is your side, if we multiply that times 4, we get a perimeter. So it's not exact, but it's close. 135.6 is the perimeter. Now remember how I said you could use, instead of 12 times the square root of 2, the 16.9? Let's use that, 16.9. Alright, I'm going to use the decimals, and this is kind of a way to see if we did this one right, because we'll get pretty close to this answer. Let me type this in real quick. 1/2 times 135.6 times 16.9. Alright, it's 1,145.82. It's not exactly the same, but it's awful close. This one really is the better answer. This is called the exact answer. So 1,152, and this is square inches. Okay, time to do some on your own. Come see me if you need any help or have any other questions.